at rational functions. So an example, we had a parent function. The one that we looked at when we did the pennies and the spaghetti problem was f of x equals 1 over x. We learned how to shift the function, and this is a review actually from first semester. So we did a Desmos activity where we knew that if we had an x, I'll put plus h here, and then I'll put a plus k. The rule here is if it was plus h right here, this was left h units, and minus h was right h units. And that did affect the vertical asymptote, which is the x equals asymptote, so this vertical asymptote right there. And the plus k was up k units, and the minus k was down k units. And that affected our horizontal asymptote if it went up or down. If our graph shifted up or down, so did the horizontal asymptote. Okay, so the asymptotes, again, x equals was our vertical, and it was at 0 unless something shifted. And our horizontal was our y equals. So if we look at this function, it is shifted left 2, down 1. So our horizontal asymptote, I should do our vertical first, how about? So our vertical asymptote would be x equals negative 2, because everything shifts left 2, or it's what makes the bottom 0. And our horizontal asymptote, everything shifts down 1, so it was at 0, but it shifts down 1, so y equals negative 1 would be the horizontal asymptote. Factoring, so remember factors are things that multiply to something, so factors of 12 would be 1 and 12, negative 1 and negative 12, 3 and 4, also the negatives 2 and 6, and so on. Methods of factoring, we have our greatest common, pulling out a greatest common factor. You had your box and circle, and you had your difference of squares. So let's see if there's some examples, otherwise maybe I'll put some up. Oh, yep, there's some examples. All right, so factor the following. So first is greatest common factor of the top. There's an x in each one of these, so I'm going to pull out an x, and then divide each term by an x. I'm left with an x squared plus a 6x plus a 9. On the bottom is difference of squares, so this would be x plus 3, x minus 3. And then I can keep factoring the top further with the box and circle right here. What multiplies to 9 and adds to 6? So that would be x plus 3, x plus 3. And here we would have x plus 3, x minus 3. Then if we talked about, let's find the horizontal asymptotes. Here, well, we talked about this case. If it's the king is bigger on the top, it's a slant asymptote, so actually I won't ask you that on the final. We can take a look at the vertical asymptotes. It's what makes the bottom 0 unless there's a hole, and there's a hole here, so we should have probably done our hole first. The hole is at what makes this equal 0, so the hole is at x equals negative 3. And there is a vertical asymptote. You look at what makes the bottom 0, and that would be positive 3. We looked at multiplying and dividing polynomials. First step is factor. And so if we take a look at the top, this is greatest common factor right here. I can divide a 9 and a 6 by a 3x, x squared and x by an x. And write what's left, so 9x squared divided by 3x, there's a 3x left. 6x divided by 3x, there's a 2 left. The bottom's already factored. We're going to flip and multiply. I'm going to do a box and circle for this one right here. We have our 2x squared, our 5x, our minus 3. We want to know what multiplies to the first and the last box. So multiplies to negative 6x squared. That adds to our middle circle 5x. Oops. And so that would be a negative 2x and a negative 3x. Let's get the outside. We know that this will be an x and an x. Our 2 has to go on the side here. 2x times negative 1 is negative 2x. X times negative 3 is negative 3x. So we're going to put that on the top of this fraction. 2x minus 3, x minus 1. The top will use a box and circle, so this will be what multiplies to 10 adds to 7. So x plus 5, x plus 2. All right, next step, see if there's any factors that are the same that you can cancel from top and bottom here. And it doesn't look like there's anything. Oh, I must have done one of these. Let's see. 2x. That's right. 3x. Oh, I must have factored this one wrong, right? Because we have what multiplies to negative 6x adds to a 5x. Okay, so this is where I made my mistake. So let's redo this. Okay, my mistake was they didn't add to a 5x, they added to a negative 5x. Okay, so what multiplies to a negative 6 adds to a 5? That would be a negative 1x and a positive 5x, 6x. Okay, now it's good. So now they multiply to a negative 6x squared and add to a positive 5x. So let's finish factoring this. 2x. I have to change this. Okay, so now the 2 has to go here. 2x times 3 is 6x, and x times negative 1. Okay, so now let's rewrite this, and then we should get some stuff to cancel. Sometimes things don't cancel, but in this one, some things do. So this will be 2x minus 1. This will be x plus 3. Okay. Now some things cancel. Let's see, these two cancel. Does anything else cancel? Looks like no. So we rewrite it 3x plus 2, and an x plus 3, all over the bottom here, which is x plus 5, x plus 2. Okay, so the steps are factor. If it's division, you flip the second one, you cancel the things that are the same, and then you rewrite it. And the last thing is adding and subtracting polynomials. So first step is factored. This one looks already factored. Next step is find the lowest common denominator, which is everything on the bottom, unless something repeats. So we have an x plus 2, we have an x plus 3, but the x plus 2 repeats. So here's your LCD. This is the goal. You want this on the bottom of both fractions, and it's already on the bottom of the first one. So the second one we're going to multiply by an x plus 3 over x plus 3, because it's missing that on the bottom. Now that you have the LCD on the bottom, you're done with the bottom till the last step. We're going to look at just the top. So the 4 we don't change. We have a 2x times this x plus 3. So let's distribute. We have a 4 plus a 2x squared plus a 6x. Let's write that in standard form, where the highest power is first. And this is all over x plus 2, x plus 3. Now here we stopped, but you can actually go further. You can pull out a greatest common factor. Let's see if this factors further. So we have 2, we have x squared plus 3x plus 2. So I pulled a 2 out of that. And then let's factor this guy. What multiplies to 2 adds to 3. So this would be x plus, multiplies to 2, adds to 3, so x plus 2, x plus 1. So there's the top of the fraction, all over in x plus 2, x plus 3. So you can cancel these guys out. So our final answer would be 2, x plus 1 over x plus 3. So for adding and subtracting, you'll find an LCD after you factor. You multiply to get the LCD on the bottom of both fractions, and you simplify the top. I think that's it for chapter 9. Yep.